Okay, yeah. This time, yeah, let's look at first question in quiz number 3. Yeah. So next week we will do quiz number 4. Okay, yeah. The first one, every SQL table must have a primary key, primary key, so as to be useful in the real world applications. Yeah. First, the answer is false. Okay, the first thing is answer is false. So then I explain a little bit. Yeah. First, we know the primary key is desirable. We like to have a primary key in every table, right? Yeah, because we can use the primary key to identify the rows. But sometimes we may not have that primary key, yeah, because sometimes we allow duplicate rows in a table. Yeah. Yeah. And although it's not convenient, with duplicate rows, it's not convenient for a table. Yeah. But we allow, yeah, because some of the applications, sometimes the data we retrieved could contain duplicate rows. Think about a table with duplicate rows. How can you give a primary key? There is no way you can assign a primary key. Okay, yeah. So, yeah. So we have to take it. Okay, without primary key, so we have to take it. Okay, yeah. So then, in our project number 1, so last time I mentioned, we have 5 tables in our project number 1. And later, I will show you the details in my video instructions. 3 of the 5 tables contain primary keys, so we can use the primary keys to do all the queries conveniently. Yeah. But 2 of them do not have primary keys, so we need to find a way. Still, we want to edit data, update data, delete data, even under the situation there is no primary key. Okay, yeah, so we will go there. So you can try to understand a little better. Yeah. All right, here. Oh, I forgot to give that one co-host, so I can control there. Otherwise, yeah. Let's continue. Yeah, all right. Now, type, entity type, that's the first one. Entity type. Yeah, usually about objects, right? When you describe objects, yeah, so we call that entity type. Yeah, employee, student, course, you know, real world objects. It could be abstract object, yeah, not necessarily physical objects. Yeah. But there is another type related to the relations between objects. Yeah. So you need to describe that. So we call the relation type. Okay, yeah. So that's also important. In our company database, we have 6 tables. 5 of them are of entity type, but there is one works on. So I remember works underscore on. That table is a relation type. Yeah, relationship. Yeah, let's relationship. Yeah. Because relation we may confuse with the table. Right? Table we call a relation. So relationship type. Okay, yeah. How do you do the mapping between 2 types of objects? Okay, Yeah. So the mapping thing. Yeah. Very useful. Mapping things. So for the mapping, we have 1-to-1 mapping, 1-to-n mapping, M-to-1 mapping, and M-to-n mapping. Okay, yeah, all different ways to do the mapping between two objects. All right, so that's false. Okay, yeah. In which of the following the order is important? Yeah, yeah. So when we talk about list of attributes, the order is important. So when you change the order, then we treat, so we get a different, let's say, projections, right? We have that projection concept. Yeah. So we treat, so different order of the same attributes as different projections. In our applications related to our business, we need to tell that difference. That difference is important. Okay, yeah. But in another situation, the second one, the list of tuples in a SQL table, the order is not important. Yeah. Because we use that multi-set concept, right? Multi-set concept. Each SQL table is a multi-set concept. Multi-set, we just add one more property to the set concept. Set, all the elements must be unique. Yeah, so this time I do here, so my remote control is still good here. All right, yeah. Yeah, we just relax that uniqueness requirement in a set. We allow duplicate elements, but we treat those duplicate elements as different copies. Yeah. Think about that. Yeah, a little bit complicated, but we need to understand in that way, specific way. All right, okay, yeah, hands on. So just remind me, I need to check your name at the end of the class. Yeah. All right, yeah. But another property, this multi-set still keep it, okay? Yeah, keeps that one. That is the order is not important. That property, multi-set still inherits that property. Okay, yeah, yeah. Next one, when we use the null value as a field value in a SQL table, we always mean that this value is unknown but exists. We have several cases, right? At least 3 cases. Yeah, actually, we could have more than that. Yeah. At least we have 3 cases. Yeah. Yeah. Unknown, there is a case, it is known, it could be known, right? It is known, but the information is very sensitive. The, high level people, they may not like to put the information there, right? Yeah. So in that situation, this null value could be used. And when you see the null value, so you know there is a warning, okay, alert. Yeah. Something, you need to do some special treatment. Yeah. You need to do some special action for the null value when you see it. Yeah. All right, so that's false. All right, next one. All the virtual tables SQL can never have physical files for. Yes, that's false. Yeah, and sometimes we like to keep physical copy. Yeah, In DBMS, it allows you to store virtual tables physically as physical files. Yeah. So then you can later use the physical data stored there. Right? Yeah. Yeah. But usually if you do not have any good reason, you do not store views. Yeah. All right. Next one, which of following is the right way for us to treat a SQL table? Yeah, this is just no. Yeah. Sometimes I give you simple, straightforward questions. Yeah. 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 Not always tricky questions. Yeah. Suppose that a SQL table does not have any key field. That's possible. Even no key field. Think about that. Okay. Yeah. Is it possible for us to find a way to define a primary key for this table? The answer is yes. Okay. The answer is yes. No. Even there is no key field. Think about field. Field, we mean individual columns, right? Each column is a field. And here, the condition you are given, there is no column that is a field of the table. That means the values for that column are not unique. The uniqueness constraint is not satisfied. But in that case, remember, we have another way to make the rows unique using composite keys. We define, yeah, we may, yeah, because so you may define a composite primary key. May, yeah, because the probability that you can define is pretty high, but not 100%. Sometimes you cannot, even if you consider composite keys, but you couldn't find any composite key. Is that possible? You couldn't find any composite key. Yeah, yes, it's possible because we allow duplicate rows, right? Think about it. When your table has duplicate rows, then no way to find any composite key. Yeah. Because if you can find a composite key, you can identify different rows. But with duplicate keys, you cannot identify those duplicate rows. Okay. Yeah. So that's why here I use may. Yeah. Okay. Yeah. All right. Number 8, there is no way that one can define a foreign key constraint with a circular reference. Yeah. It's false. Yeah. We can, yeah. So remember, we use that alter table statement, right? Yeah. Alter table. Yeah, here, let me review this part using that alter table statement. Yeah. All right, so here, just review a little bit. Because when you need to do this, use a foreign key that reference the table itself. You cannot define foreign key constraint inside that table definition. Because when you refer the primary key of your this foreign key, the table does not exist. So you're not allowed to do that. DBMS will not allow you to do that. The DBMS checks if the table already there. All right. Yeah. So you cannot do directly inside the table definition. But this order table allows you to do modification after the table is created. So you just define the table first. Then later, when this table is created, then you're allowed to alter the table by adding this foreign key constraint. So that's simple. Yeah. So just check your understanding of that simple point. Next question. Is it possible that there is no order defined? Krishna here also. Yeah. No order defined for a field of a SQL table. Is it possible there is no? Yeah, it's possible, right? Yeah. Although we know most of the time, the order, yeah, we can even say 99 point something percent of the probability the fields are ordered, but not 100%. Okay, 100%. Yeah, but in class, I couldn't give you a simple example. But I give you another example. Another example you can consider, the binary data case. Think about, in the table, you can store binary data, right? Image, multimedia data, you can store directly inside your tables. But when you do that, is there an order you can consider, right? It's very hard to define any order for that kind of data. Yeah. Yeah. So that's something I put it in that, 0 point something percent. Very rare, but it could happen. It could happen. All right. Yeah. Is it possible? No order. Answer yes. All right. Last question. Given a SQL table, is it possible that this table does not have any key? Yeah. We pretty much covered this one before, right? Yeah. Is it possible it does not have any key field? Yeah. And we talked about it from different angles. Multiset. Yeah. Multiset is the case when you have duplicate rows, then no key field. If you have a key field, then you cannot have duplicate keys. Right? You cannot have duplicate rows. When you have a key field, there is no duplicate rows. Okay, yeah, all right. So that is, yeah, so we finish quiz number 3, yeah. So next, I'd like to talk about homework assignment number 1. Pretty noisy here. Yeah, I need to ask someone to fix it. All right, yeah. First question, when we deploy PHP web applications in the Apache HTTP web server, we need to deploy them in a document root folder. Yeah, here, this concept. Yeah. I talk about a little bit. What is the folder name of the document root? htdocs, right? htdocs. Yeah. you need to really locate this folder and put all your web applications in this folder. Then Apache server would expose its content to the outside world. That's simple. Yeah. And for different servers, let's say web servers. Here we talk about web servers, not database servers, web servers. Yeah. For different web servers, this special folder must be somewhere in the server, okay, to expose the web content to the outside world. Yeah. So for example, in Tomcat, some student, learning that Java web technology in Tomcat, its document root called a different name called web apps. Okay, yeah. So you need to deploy your web applications into this folder in order to access them from the web. Yeah. Okay. Yeah. So this concept. All right. Here, the second one we talk about in PHP, in order to concatenate two strings to form a new string, which of following symbol do we use? This dot operator. Yeah. PHP use this dot special operator. Java use this plus. Java, C++, JavaScript, many, yeah, but the B is SQL, right? In SQL, we use double vertical R's, yeah. So you can see different programming languages. This symbol, concatenation symbol, could be different. Yeah. The number 3, yeah. So this one embedded, right? Yeah. In one of our quiz questions, we test that. So here, basically the same question. Through any without going through remote. So that's we call it embedded. Embedded database. Yeah. Oh, sorry. Embedded database. Okay. Yeah. Oh, yeah, possible. Yes. Actually, it should be yes. This should be no. Okay. And embedded in that one, we use the database engine because there is no server there. We use database engine to power the queries. Yeah. And last time I mentioned the whole database DBMS size, pretty small, DBMS size, pretty small, less than 1 megabyte. Okay, so you can embed easily in many small devices. Yeah. Okay. Yeah. So this option is useful. This background knowledge is useful in case you need it when you solve real-world applications. Yeah. Here, yeah, because I cannot show you examples. Otherwise, you will get a better impression. Yeah. All right. I used a few Java embedded DBMS. Yeah. So one is called Derby. Derby DBMS. All right. Yeah. Another is called, yeah, I forgot its exact name, but as I remember, SQL. Yeah, similar to that. Yeah. I use 10 something years ago, I used this a lot. Yeah, but all right. Number 4, in database design, data normalization, not denominalization, should always be implemented to avoid any redundancy to say false. Because we may need denormalization. We like to have some controlled redundancy, right? Yeah. Controlled redundancy for better performance. Prevent already here as member. Yeah, I don't know, maybe not. Yeah. Number 5, which of the following do the store procedure belong to? Definition as database definitions. You need to write SQL step because we know each stored procedure just a sequence of SQL statements. Okay, and you store that sequence of statements under that stored procedure object inside DBMS. Yeah, so we treat part of the database definition. Yeah. In SQL, when we compare 2 strings with all the characters in digits, the more digits a string has, the larger the value of the string is false. Although the digits, for the order we use, non-numerical order, alphabetic order. Alphabetic order, not numerical order. Yeah. Although here I mentioned digits, right? Yeah, but digits we treat as characters. Yeah. Because the data type is the string data type. String data type, so we use the alphabetic order automatically. Yeah. Yeah. So yeah, and actually, yeah, I remember you have some question. Yeah, probably later. Yeah, digits. String with fewer digits could be larger in string values than string with more digits. All right. Number 7, only textual and numerical data can be stored in the traditional database. False, binary data. Okay? So here, binary data. So not textual, not numerical. Okay, yeah. Number 8, every traditional or non-traditional database must have metadata. Yeah. For traditional, it's true, right? Non-traditional, it's false. Non-traditional, we refer to NoSQL. Yeah. NoSQL, remember in our review session last time, we talked about schema, database schema. And for non-traditional, there is no schema, no database schema. That means no definition. You do not need to even define your data types because all data types are in those key value pairs. Why you need a metadata? You do not need any description for key value pairs. No description needed. No description needed for key value pairs. Yep. So you can see completely different. Yeah. Simple structure. Yeah, last time we talked about simple structure, complex structure. Yeah. So this simple structure, simple supporting fast search operation. So there is good reason people do it in this way. All right. Number 9, if a SQL table can be stored based on a particular column, can be sorted, sorry, sorted based on, yeah. Then we can say that this column must correspond to a key that's false. Okay? Because key corresponds to unique values, right? But a table that could be sorted based on, so sorted, rely on this property, total order property. If one particular column has this total order property, then it can be sorted based on this column. Yeah, that's enough. You can have duplicate keys. So for this particular column, duplicate key values are allowed. You can still do the sorting, right? So when we do the sorting, we do not require unique values. Think about that. Yeah. Total order property. Yeah. Do not get confused. Yeah. Those concepts. Number 10, if a SQL table contains a foreign key that references the table itself, circular reference, we can still find a way to add the foreign key constraint. Yeah. Alter table, right? Yeah. So here you can see for the same concept, same topic, I may test it multiple times, but from different angles. Yeah. I may write the sentences in different ways, but basically checking the understanding of the same concept. Yeah. That could happen. All right. So here, by that alter table statement. All right, yeah. Number 11, if we can define a key for a SQL table, then we can say that there exists a column in the table that has unique value false. Okay, yeah. So here you can see the same concept, but I check your understanding from different angles. Make sure your understanding is very solid. So here, why? Yeah, because consider that there is a case the table may have the composite keys. Okay, yeah. Because for a single column, you may not find any key. or a single column. But can you use multiple columns to form a key as a composite key? Yes, you can. Okay, yeah, yeah. For example, in our university table prerequisite, right? Yeah, prerequisite. Yeah. So example, yeah. In our university database. Look at that prerequisite table. Prerequisite table. Yeah. Yeah. Right. Yeah. And you cannot find any column that has unique values. No. But if you look at two columns, then you can get unique values. Composite key. So you can define a composite key in that prerequisite table. Okay, yeah. Yeah, because this means you can use this kind of composite keys to identify the rows. When you can identify the rows, you can access one particular row without any confusion. Yeah. Otherwise, if there is no this property, composite key property, then you may have trouble to access individual rows. Yeah, think about that. Yeah. But for our project, fortunately, those two tables, we have two tables without primary keys. Those two tables without primary keys, they have composite keys. Yeah. So we use that property. Okay. Yeah. So we can identify different rows based on some hidden composite keys, because we do not declare any composite key for those two tables. All right. Yeah. Oh, concatenation. Yeah, why repeat? Yeah, this one. I mean, just all right. Yeah, I got myself confused. All right. Oh, yeah, for different language. This time SQL. Yeah. Yeah. Even you know, they look the same, but yeah, the answers are different. Yeah. Number 14, in order to avoid ambiguity, it is not allowed to make attributes in two different tables have same name. False. It is allowed, but we can use table names and aliases used to qualify them. Right? Yeah, to qualify them. So no problem. All right. Oh, sorry. Number 15. When we execute a transaction, we either execute it in its entirety or do not execute it. What is the name of this property? Yeah. Atomicity. Atomicity. Atom cannot be separated. Okay? So we emphasize that no separation property. Okay? So this property, no separation. That property. Yeah. All right. Number 16. Any SQL system always returns a set of tuple. Here. Yeah. There is a small problem here. Set. Yeah. So accuracy, small accuracy problem here. To be more accurate, it should be multi-set, not. Because when we talk about set, we do not allow duplicate rows. If we allow duplicate rows, then we call multi-set. Yeah. In SQL, that difference could impact our query result. Yeah. Because later we have two different types of set operations. Union. Union operation and another version, union or operation. Okay, union, so that's the set version. Okay, union or, that's the multi-set version. Think about that. Union set version, that means when you apply union set operation on your tables, you treat your tables as set objects. Okay, so that means duplicate rows will be removed to make a set, right? If your original tables have duplicate rows, when you apply the set operation, duplicate rows are removed to make them set. Okay, yeah. But if you like your tables to keep the duplicate rows, then you should use the multi-set version. Otherwise, you accidentally remove the duplicate rows. Think about that difference. So that's the reason we emphasize these two concepts, set, multi-set, a lot, because your query result could be different. Okay, yeah, all right. Number 17, a table is allowed to have multiple secondary keys. Yeah, no problem. Multiple secondary keys. Then we can solve this table based on different secondary keys. Do binary search based on different secondary keys. Yeah, so the background, because we can create indexes or indices, indexes, several indexes based on these keys. Yeah. By the way, here, yeah, because index is this topic in module 5. And our midterm, we only cover module 1 through module 4 for midterm. And we leave module 5 and module 6 to the final. Okay, yeah. So you do not need to touch module 5 content. Yeah. Just focus on the first 4 modules. Yeah. So that means the index topic. You do not need to look at that. Yeah. After midterm, then you focus on the new content. All right. Number 18, when we use the equal operator to compare the values of two rows in a SQL table with respect to one column, are we required to have an order defined? No, because the equal operator, even no order is defined, we can do the exact comparison, right? But you cannot do greater than, less than comparison. Greater than, less than rely on total order. Rely on total order. But equal, you just compare for the exactness. Then the order is, total order is not needed. Yeah. So this property also related to the hashing. Remember, I mentioned that hashing technique before. Hashing technique, you only need to compare values with exactness. You do not need an order. No order needed. You can apply hashing technique. Yeah. For the binary search, you need a total order. Yeah. So here, yeah, let me just recall a little bit. Okay. Yeah. The binary search. Okay. Yeah. Total order needed. Otherwise, you cannot do binary search. For hashing, no need to have total order. Yeah. That's something good and also something bad, you know, an advantage, disadvantage. The advantage part is without total order, you can still apply hashing. So that make hashing more useful, broader. But the disadvantage part, without total order, even if you can apply hashing technique to support a fast search, but there is no order information you can use. That's not convenient. You cannot do sorting. Even if you have some fast search operation on your data, but if you want to sort your data, it's still very expensive. So that is the disadvantage for that hashing technique. Yeah, but that's the module 5 topic. Yeah. So this one, module 5 topic. So you will see this part in the final. Okay. Yeah. Yeah. Then number 19. So this is the question I mentioned before, but this is a concrete example case. The previous one, we talked about some abstract way for the order of strings, but here you see the concrete strings for comparison. And here, when we compare, we use alphabetic order. Sometimes we also call dictionary order. Dictionary order. Okay. Yeah. So you look up in a dictionary. Yeah. Imagine that. How do you look up a word in a dictionary? You look at the first character. Okay, search for the location, first character, based on the first character. Which one largest? 9 is the largest. Only when the first characters are the same, then you look at the second character. If the second characters for a few strings are the same, then you look at third characters and so on. Okay, yeah, in that order. Yeah. All right. Yeah, so this one, the special thing is that apostrophe, and in one class I mentioned that, double that apostrophe. Yeah, so in SQL, double that apostrophe. Yeah. All right, so here, so let me, yeah. For the remaining a few minutes, let me just talk about this question. Yeah, the remaining we can leave next time. In SQL, when we use the like operator to find strings that contain a substring ABCDs, how to write the pattern to be matched for. Yeah, so you only need to write a pattern part. Yeah, we know, follow the like operator. All right, yeah, contain the substring. So before it, you have, everything before it, A, B, C, D, apostrophe, double it. All right, yeah. Otherwise, you get confusion. Like this, how about that? Okay, yeah, as simple as this. Yeah, double it. Yeah. So that is the SQL way, right? This is the SQL. Yeah, because for different languages could be different. Yeah. The different languages, yeah, because in SQL, the single quotes has special meaning. Yeah, special meaning. Yeah. So we have to treat differently. Yeah. And yeah. Right. Yeah. And here I like to mention another possibility. Yeah. Another possibility for this apostrophe thing. Yeah. Because in HTML, there is an option to use HTML entity symbols. What's that? In HTML, there are a large number of entity symbols defined using the special notation. Yeah, here, for apostrophe, let me just show you one example for that entity symbol. Every entity symbol start with the ampersand sign, ampersand. Then the symbol, the main body of the symbol, prime. Yeah, because apostrophe, people also call prime. Okay, prime. And entity symbol end with semicolon. Start with ampersand, end with semicolon. That is the pattern for an entity symbol in HTML. So apostrophe, if you use it in HTML content, you can use this entity symbol. All right, yeah, an option. So this is an option. Okay, yeah. All right, let me stop here. The remaining, so we will continue next time. The remaining